Have you ever stopped to think about how a simple green plant can be transformed into millions of tons of the most consumed candy on the planet? Behind every teaspoon of sugar lies a monumental story of engineering, science, and agricultural precision. From the vast tropical fields to the colossal factories that never stop, sugarcane undergoes a sophisticated process that harnesses absolutely everything: energy, fiber, and sweetness. Sugarcane fields stretch out like a green ocean under the tropical sun. In countries like Brazil, India, and Thailand, these vast plantations cover kilometers of fertile land where one of the most consumed ingredients on the planet is produced. Behind this simple appearance lies an industry that combines science, technology, and precision on a massive scale. Sugarcane is not grown from seed like other vegetables. Its cycle begins with fragments of the stalk itself, known as cuttings, which contain small buds capable of generating new plants. These pieces are placed in furrows of moist soil, and within a few days the roots begin to spread. In a matter of weeks, the field is covered with perfectly ordered rows that grow vigorously in the warm, humid climate of tropical regions. For months, the plant absorbs water, minerals, and sunlight, storing natural sugars in its thick stalks. Throughout this process, farmers constantly monitor soil and crop conditions. Today, many plantations use sensors, soil analysis, and satellite systems to determine the precise amount of fertilizer or the ideal time for irrigation. Sugarcane is resilient, but it requires attention. Pests, fungi, or drought can reduce yields if not controlled promptly. When the stalks reach maturity, after about 10 to 12 months, the most important moment arrives: the harvest. In the past, this was done entirely by hand, but on modern farms, the task is carried out by specialized harvesting machines designed to work with impressive speed and precision. These bus-sized harvesters move along the rows, cutting the stalks almost at ground level. As rotating blades cut and shred the remaining leaves, powerful fans separate the usable material from the waste. In a matter of seconds, the stalks are cleaned, cut into segments about 30 centimeters long, and stored inside the machine's hopper. When the hopper is full, the chopped sugarcane is transferred directly to trucks that keep pace with the harvester. The work doesn't stop. The flow is continuous to prevent the sugar contained in the stalks from degrading. A single harvester can collect more than 100 tons per hour, a figure that would be unthinkable without modern agricultural mechanization. The plant material left in the field, such as dry leaves or tops, is not discarded. It is left on the ground, forming a protective layer that helps retain moisture, prevents erosion, and returns nutrients to the soil. This practice, known as cover cropping, demonstrates how the industry is increasingly seeking a balance with the environment. Once harvested, speed becomes essential. The sugarcane must reach the factory within a few hours to preserve its quality. Trucks loaded with the freshly cut raw material depart for the nearest sugar mills, where the industrial process begins almost immediately. Upon arrival at the plant, each vehicle first passes over a digital scale that accurately records the weight of the load. Then, a sample is taken and sent to the laboratory to analyze the sucrose content, moisture, and purity of the material. This data not only determines the quality of the product, but also the price the producer will receive for their sugarcane. After quality control, the trucks unload their contents into enormous hoppers. From there, conveyor belts carry the stalks to the washing section. This step is crucial for removing mud, dust, stones, and any other impurities that could damage the machinery or affect the sugar's flavor. Powerful jets of water and mechanical agitation systems thoroughly clean the cane. The water used is filtered and reused several times, reducing consumption and environmental impact. Once clean, the sugarcane passes through a closed conveyor belt system that directs it to the noisiest and most energy-intensive area of the entire plant, the milling area. Here, the real transformation begins. High-speed blades cut the stalks into smaller pieces. These fragments are then pressed in a series of mills with giant metal rollers. Each set of rollers exerts tons of pressure, crushing the plant fiber and releasing the juice containing the sugar. The resulting liquid, greenish-brown in color, is known as raw juice. It contains sucrose, plant fibers, and small particles of soil. The solid material left after milling, a dry, fibrous mass called bagasse, becomes a valuable byproduct. Instead of being discarded, it is used as fuel to power the mill's boilers. When burned, the bagasse generates high-pressure steam, which powers turbines that produce electricity and provide the heat needed for the subsequent stages of the process. Thanks to this system, many factories achieve energy self-sufficiency and even generate a surplus that is sold to the electrical grid. Thus, sugar not only sweetens the world, it also energizes it. Meanwhile, the extracted juice undergoes a purification process. First, it is mixed with hydrated lime, which neutralizes its natural acidity and causes impurities to clump together into larger particles. Then it is heated and transferred to clarification tanks where the sediment settles to the bottom. The clear liquid, known as clarified juice, is carefully separated from the remaining sludge. That sludge isn't wasted. Because it contains nutrients and organic matter, it's dried and used as a natural fertilizer in the sugarcane fields themselves. Every residue finds a new purpose within the production cycle. The clarified juice is then sent to the evaporation stage, where most of the water is removed. This is done using multiple effect evaporator systems. Each evaporator operates at a slightly lower pressure than the previous one, using the steam from the first to heat the next, thus reducing energy consumption. As the water evaporates, the juice concentrates into a thick golden syrup with a honey-like texture. This syrup, called mother syrup, is the base for the formation of sugar crystals. If greater purity is required, the syrup can be further filtered or passed through activated carbon to remove unwanted colors. The next step is crystallization, a precision process where chemistry and physics combine with engineering. The concentrated syrup is introduced into large crystallization tanks. Inside these sealed vessels, temperature, pressure, and agitation are controlled with extreme accuracy. To begin the process, small crystals of pure sugar, called seeds, are added to serve as nuclei. As the dissolved sugar adheres to them, the crystals gradually grow to the desired size. This process can take several hours, and any temperature change or excessive movement can alter the outcome. Once ready, the crystals are mixed with a thick substance known as molasses. To separate them, the mixture is passed through centrifuges that spin at high speed. The centrifugal force pushes the molasses against the walls of the drum, while the clean crystals remain in the center. The type of sugar obtained depends on how thoroughly the product is washed and purified. If the crystals are washed completely, the result is refined white sugar. If some of the molasses is retained, brown sugar is obtained, with its characteristic golden color and more intense flavor. Next, the wet sugar passes through drying tunnels where hot air currents reduce its moisture. Then, the dried crystals are sifted to classify them by size. The finest crystals are used for baking and the coarser ones for home or industrial use. In the most modern plants, sugar can undergo further refining to achieve near 100% purity. At this stage, it is dissolved again, filtered through activated carbon, and recycled. The result is a white, bright, and completely uniform sugar with a purity level of 99.9%. Meanwhile, bagasse and other waste continue their own cycle. In parallel facilities, the bagasse is washed, shredded, and pressed into a moldable pulp. This pulp is then transformed into biodegradable products, such as plates, trays, and food containers. After being heat molded and coated with a waterproof plant-based layer, these products can decompose in less than 3 months, offering a real alternative to single-use plastic. Even molasses, the thick, dark byproduct left over after sugar extraction, has a use. It's used as a raw material for making ethanol, as animal feed, or as a base for rum production. Thus, every part of the sugarcane plant has a useful purpose. Once the crystals are ready, the sugar moves to the final stage, packaging. This process takes place in enclosed, controlled areas to ensure complete hygiene. Automatic weighing machines precisely dispense the exact amount that will go into each bag or sack. Once purified and crystallized, the sugar reaches the final stage of its journey, packaging. At this stage, precision and hygiene are essential. Inside large, enclosed and controlled rooms, the product passes through automated machines that weigh, dose and seal with millimeter accuracy. Every grain counts, and technology ensures that nothing is wasted. Sugar is available in a variety of formats depending on its intended use. For home consumption, it is packaged in small bags or packets ready for supermarket shelves. For the industrial sector, sacks can weigh up to 25 or 50 kilos, while large commercial operations and exports use bulk containers of several tons. This versatility allows it to cater to everyone from a single family to a large-scale food factory. The packaging lines operate at an astonishing pace, filling, sealing and labeling hundreds of units every minute. State-of-the-art robots and sensors monitor every step of the process, detecting any irregularities, whether in weight, closure, or packaging integrity. Nothing is left to chance. Each bag, box, or container is precisely identified with labels that include essential information: batch number, production date, sugar origin, and a unique traceability code. Thanks to this system, any package can be traced from its point of origin to the exact location where it will be consumed. This level of control not only guarantees quality, but also transparency and consumer confidence. Once labeled, the packages are carefully grouped, stacked on pallets, and wrapped for transport from the distribution centers. The sugar begins its final journey to supermarkets, bakeries, candy factories, and export ports. Thus, the cycle is complete, from the fertile land where the sugarcane grew to the table where it sweetens the daily lives of millions of people around the world. Behind every teaspoon of sugar lies a chain of carefully coordinated processes. From the plant's photosynthesis to the automated systems that control humidity in the packages, everything adheres to a principle of precision and maximum efficiency. Nothing is wasted. Sugarcane is transformed into multiple products: energy, fertilizers, eco-friendly materials, ethanol, and of course, sugar. What was once considered waste is now an essential part of a more sustainable model. This balance between technology, nature, and efficiency makes the sugar industry a prime example of continuous innovation. What was once a handcrafted process using machetes and fire is now a global, automated system driven by data and clean energy. Each crystal that reaches your coffee cup represents a story of effort, science, and industrial evolution. A journey that begins with a tropical plant and ends with a universal product that sweetens everyday life across the globe.